Alright, which resonance structure contributes the most to the overall picture of this molecule here? Right, so first we want to be able to remember the concept of what Lewis structures actually are, right? Right? These are all Lewis structures, potential Lewis structures for this molecule. And so the idea with the Lewis structures, right, it's a simplified model of what a molecule actually looks like. You know, so we do that in order so we can guess some of the properties of the molecule, right? But in the end, it's simplified. You know, drawing electrons in lines and dots. You know, electrons really in clouds and kind of just not in a single place at once, and quantum tunneling and everything that's going on with electrons popping in and out of space, or however you would describe it. A little beyond what the Lewis structure actually shows, right? So we can draw a Lewis structure in multiple different ways, as in the case with resonance. What we're actually doing is showing which Lewis structures contribute to the overall picture of the molecule, as in thinking that the actual molecule, right, it's somewhere in between, kind of on a continuum between the different types of resonance structures that we use to represent it. Hopefully that made sense, right? But so in the end, the resonance structures that are most stable will contribute more to the overall picture of the molecule. So to determine the stability, we're going to look at formal charges on individual atoms, right? And we're going to try to follow the octet rule. So for formal charges on individual atoms, we want to pay attention to the electronegativity. So for electronegativity, O is the most electronegative compared to N, which is greater than C in terms of electronegativity. So we'd like to see minus charges on O, plus charges on C, or less minus charges on C, I should say. So let's just look at A. Let's go through these, right? O has a minus charge. That's good. It's the most electronegative. C has a positive charge. Yes, it's the least electronegative, but we're breaking the octet rule here, right? It has 3 bonds, no lone pairs of electrons, right? We want 4 things coming from carbon. There's only 3. So we can cross off A. Same with B, right? Only has 3 things coming from this carbon. Okay, so C, now we have a -1 charge on O and a plus charge on N. So that's a possibility. Put a check mark there. Right? Okay, and this one, D, is just the opposite, right? We have a plus charge on O and a minus charge on N, but we prefer a minus charge on an O because that'd be the most electronegative. O, with more protons in its nucleus, has the ability to sustain a greater, more electron density, right, on its outer shell, I suppose you'd say, right? So you can cross off D anyway, right, and go with answer's got to be C.